Imagine living in space for months without feeling the weight of your own body. It might seem like a constant floating adventure, but the truth is, the absence of gravity can have serious consequences on an astronaut's health. Without that continuous pull downwards, what happens to muscles? What about bones? The human body is designed to live on Earth, where gravity is always present, keeping us steady and strengthening our structures. In space, everything changes. Muscles, no longer having to work against gravity, begin to weaken. Bones, no longer bearing weight, lose density. It's as if the body thinks, why keep everything strong if it's not needed? However, once back on Earth, gravity resumes its pull, and that's when problems can arise. But don't worry, astronauts aren't just sitting idly by. They have a special routine packed with exercises and adapted equipment to combat these changes. You'll find out how they manage to stay fit, even while floating hundreds of kilometers above our planet's surface. Stick with me, because what they do is amazing and could completely change how we view life in space. Gravity in space doesn't completely disappear. One very interesting thing about space is that gravity never truly disappears. People often imagine that as soon as you leave Earth, you're free of any force pulling you down. But the reality is, gravity is present everywhere. The difference in space is that it becomes much weaker because you're so far from planets or other large bodies with strong gravitational forces. That's why astronauts appear to float inside their spacecraft or on the International Space Station. It's not that there's no gravity at all, but it's so reduced that things seem loose. It's similar to playing in a pool and trying to float on water. You still feel gravity pulling you downward, but the water gives a push upward, making you feel lighter. In space, without water's help, you're still being pulled by gravity, just much more gently. There's no air in space to carry sound. On Earth, we're used to hearing sounds all around us because the air serves as a medium for sound waves. When someone speaks, sound travels through the air in all directions, reaching our ears. Space, however, is different. It's what we call a vacuum, meaning there's no air or other material for sound to travel through. It's like trying to shout underwater. The water makes the sound move differently, but in the case of space, there's no medium at all for sound waves. That's why, contrary to what many movies portray, massive explosions or the noise of spacecraft and meteors are completely silent for anyone outside. Imagine a movie theater where the visuals are stunning, but the sound system is turned off. In space, you can see things happening, like a star exploding or a ship breaking apart, but you won't hear any of it. Astronauts can hear sounds inside their spacecraft or helmets because there's air there. Outside, though, it's complete silence, even when spectacular events are unfolding all around. Space isn't completely dark. While we often picture space as a pitch-black void, as if all the lights are turned off, it's not entirely black. Sure, it's much darker than the night sky we see on Earth, since there's no atmosphere scattering sunlight to create the blue hue we're used to. In deep space, far from stars and planets, the darkness is profound. But there's always some light. Stars, even though they're far away, send out rays of light throughout the cosmos. If you look towards a galaxy, you'll see millions of tiny bright points, each emitting its own light. Moreover, planets reflect starlight. That's why astronauts on the International Space Station aren't in complete darkness. They can see sunlight shining brightly from one side and Earth's reflected light from the other. Moons also contribute by reflecting light and brightening the area around planets. So space isn't a completely unlit place. It's more like a vast theater where the main stage may seem dark, but there's always a light source in the distance. Even in the most remote regions, the glow of stars and other celestial objects reminds us that space is full of light, traveling across unimaginable distances. Stars have different colors. Many people think all stars are the same, just white points in the sky, but that's far from true. Stars actually come in a range of colors depending on their temperature and age. This means they can appear red, yellow, white, or even bluish. It's like the universe is a giant stove with burners set to different temperatures. A blue star, for instance, is incredibly hot, with temperatures soaring beyond 30,000 degrees Celsius. A red star, on the other hand, is cooler, still very hot by our standards, with temperatures around 3,000 degrees. In between, you'll find yellow and white stars, like our sun, which is a yellow star. Beyond temperature, a star's color also depends on its composition and stage of life. Younger stars tend to be hotter and bluer, while older stars, which have used up much of their fuel, become cooler and redder. When we look at the night sky, the star's light may seem uniform at first glance, but if we pay closer attention or use a telescope, we notice differences in their colors. Each hue reveals something about the history and personality of each star, making the universe not only immense, but also incredibly varied and colorful. Black holes don't suck up everything around them. It's easy to picture a black hole as a cosmic monster, devouring everything in its path, but that's not quite how they work. A black hole is simply a region of space where gravity is so strong that nothing, not even light, can escape. This happens when a massive star collapses under its own weight, forming an extremely dense point. However, this gravitational pull only affects objects that come very close. Imagine a whirlpool in a river. If you're far enough away, the current won't pull you in. Only if you get very close will you be dragged in. Similarly, black holes don't go hunting for planets or matter. A black hole the size of the sun would have the same gravitational effect as the sun, as long as you kept the same distance. It wouldn't suddenly suck in Earth or other planets just because it became a black hole. In reality, an object needs to come close enough, crossing what's called the event horizon, to be irreversibly pulled in. Outside this boundary, things keep orbiting as usual. This means black holes can exist in space without causing random destruction. They're simply an extreme cosmic phenomenon, not a giant vacuum cleaner. Space travel takes a long time. Traveling in space is very different from hopping on a plane or driving a car. Even with our fastest spacecraft, the distances between planets and stars are so vast that the trips take an astonishing amount of time. For example, a journey to Mars, our neighbor in the solar system, can take 6 months to a year, depending on planetary alignment. And that's with today's advanced technology. If we wanted to travel to the closest star, Proxima Centauri, using current spacecraft, it would take tens of thousands of years. Space is so vast that measuring distances in kilometers no longer makes much sense. Scientists use light years, how far light travels in a year. Even light, which is incredibly fast, takes over 4 years to reach Proxima Centauri. Now imagine how long it would take for a much slower spacecraft. That's why space travel requires careful planning and patience. It's not a quick trip you can do in a day. It's a long journey that needs plenty of resources, food, water, and energy. In addition, scientists and engineers are always working on ways to make these journeys faster and safer. Technologies like nuclear propulsion or solar sails are being studied so that in the future we can reach distant destinations in less time. But for now, space travel remains a venture that demands a lot of waiting and preparation. Astronauts exercise in space. In space, astronauts spend most of their time in very low gravity, which can cause some problems for their bodies. Without gravity constantly pulling down like on Earth, their muscles and bones don't have to work as hard, and this can lead to weakening. That's why, even in an environment where everything floats, it's crucial that they exercise every day. On the International Space Station, there are special exercise machines to help astronauts stay fit. For instance, they have a type of treadmill where they're strapped in so they don't float away while running. They also use a device that simulates weightlifting, but without actual weights. Instead, resistance comes from springs or elastic bands. This helps keep their muscles strong, like when you pull on a resistance band during a workout. Exercising in space also supports blood circulation and heart health, since the body isn't used to being in low gravity for long periods. Even though it might seem odd to run or cycle while floating, it's essential so astronauts can return to Earth in good health. Moreover, daily exercise helps improve mood and energy levels, making the routine in space more balanced and productive.